So we are trying to find this target. This is our target. And we know that the meaning of V1 bar is dV dN1 at constant N2. There's no bar on the dV, right? The hint was to solve this for V. So we solved it for V, right? And then we know that V1 is equal to dV, all right, dN. So we're going to take d of V, so d of all of this, dN, all right? So put this, it's d dN of all of this, right? So this goes here, right? And what is that equal to? That is equal to V1 bar, because it says right here, V1 bar equals dV dN, all right? dV, this is d, this is all of the V, dN, all right? Okay. Now, let's take the derivative. So this is distributing out the V bar, blah, blah, blah. And then we're going to take the derivative. So the first one here requires the product rule, right? So the derivative of V bar times N1 with respect to N1 is going to be a function of the first one, right? So there it is, V bar, derivative of the second one. What's the derivative of N1 with respect to N1? Well, the derivative of that is just 1. It's like dx over dx. So there's the 1, right? Plus function of the second one, which is dN1, times derivative of the first one, which is dV bar dN1. dV bar dN1. Okay, so this is the first term, the derivative of the first term. Now for the second term, this N2, this is held constant because we're doing this at constant N2. So we're going to take the derivative of this, but then keep the constant, right? So derivative of this, dV bar dN1, but keep the constant. This is a constant N2, okay? Cool. So, now, next step is to simplify, right? So we're going to multiply this by 1, which is just V bar, and then we're going to have this, and we're going to have this, right? So writing that out, so we've got the V bar, we've got this, which was that, we've got this, which was that, okay? Now, let's see. Notice that this is dV bar, and this is dV bar dN1, but this is also dV bar dN1. So I can I can factor out dV bar dN1. So if I factor out dV bar dN1, I'm going to get dV bar dN1 times N1 plus N2, yeah? So copy everything down, all right? There it is, V1 bar equal to V bar, just copy that down, plus the factored out dV bar dN1, all right? Now, what is N1 plus N2? Now, to make things complicated, you can just think of N1 plus N2 as N2 over X2. Why? Let me show you why. So you can think of N1 plus N2 as N2 over X2 because if you have N1 plus N2 over N2, okay, this is the reciprocal of X2, right? X2 is equal to N2 over N1 plus N2. So this is 1 over X2. But if I want to cancel out the N2, multiply both sides of this by N2, N2's cancel out. So N1 plus N2 is just an easy way of saying N2 over X2, right? So wherever I see N1 plus N2, I'm just going to write N2 over X2. You'll see why in a moment. So here I see N1 plus N2. Instead of that, I'm going to write N2 over X2. Okay, now, notice that I'm approaching the target because I have an X2 here, right? What was the target anyways? The target was V1 bar equals V bar minus X2 dV bar dX2 at constant N2. So I have to have an X2 out here, all right? I've got this. You want to see? I've got that right there. I've got that right there, all right? That's what I wanted. But now I need an X2. But I don't have an X2. I have an X2. I don't have an X2 on top. I have the X2 on the bottom there. Oh, that's no problem because I can just multiply this by X2 over X2. And I'll have X2 squared down here, and I'll have an X2 on top. You see? This is just equal to 1. So I'll have an X2 up there, but I'll have X2 squared on the bottom there. You see that? Why would I do that? This seems like a taking the hard way. I mean, this seems like doing the reverse of simplification. I would do this because while we were talking together online, we found that negative n2 over x squared, x2 squared is equal to dn1 dx2. Do you remember that? While we were talking online, we found that dn1 dx2 is equal to negative n2 over x squared. That's what we found. And to use the teacher's other hint, dv bar over dn1, dv bar over dn1, how do I make this look like this? What the target was. The target was dv bar over dx2, right? So the way I make this look like that is, the teacher said put dn1 here, dx2 here, and then the dn's cancel, and you get dv bar over dx2. But what is this? Remember, this is negative n squared over x squared. So that means wherever I see negative n squared over x squared, I can put dn1 dx2. All right, so we'll put the finishing touch now here. So this v1 bar is equal to v bar. So I'm going to put negative what? dn1 over dx squared. So if I have a positive here, then I have to put a negative here. So negative dn1 over dx squared. All right, so this is going to be minus dv bar dn1. Oops, dn1. So the minus is there, and this is the x squared. I keep the x squared. I mean the x2. I keep the x2, and then this here, this mofo, this guy is nothing more than dn1 over dx squared, dx2, dn1 over dx2. So these cancel, and I get v1 bar is equal to v bar minus x2 times dv bar dx2 at constant, whatever the constant thing was. It was n2, at constant n2. Okay, bye-bye.